Okay, let's give you guys some more practice. So use the ratio test to determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to use the ratio test, we will need to know the value of this thing here. So an plus 1 would be this, and then an would be this. But when you come to do this by yourself, just try to jump straight from here to here. So here you've got one thing divided by another thing. That's the same as you getting that one thing multiplying by the reciprocal of this, which will be this. But when you come to do it on your own, try to jump from here to here straight away. So now it's just a matter of tidying this up. Oh, sorry. When you get to this stage here, have a quick glance. N is moving from 0 to infinity. So when you get to this stage here. You know n is moving from 0 to infinity. So this will never be negative, this will never be negative, this will never be negative, this will never be negative. So you can just discard the absolute sign. So that will then become this. So now it's just a matter of tidying this. It's just a matter of tidying this thing up. So to tidy this up, 7 to the power of n. That's the same as, well, if you visualize this as 7 to the power of n times 7 to the power of 1. So this n will cancel out with this n here. So that will then give you this. That will then give you this. And then when you get to this stage, you're trying to find when you get to this stage here, you're trying to find the limit of this as n heads towards infinity. This is a constant, so take it out here. So that will then give you this times 1 over 7, because 1 over 7 is a constant and it's the n that's moving about. So when you're here, it is n that's moving about. This here is a constant; it doesn't contain n, so you can take it out. That will then give you this. So now it's just a matter of this block multiplying with this. When you get to this stage, divide top and bottom by the same thing. Divide top and bottom by 3 to the power of n, 3 to the power of n. Because ultimately, you're trying to find the limit of this thing here. So divide top and bottom by 3 to the power of n. So this thing divided by 3 to the power of n will give us this. 4 divided by 3 to the power of n, that will then give us this. 3 to the power of n divided by 3 to the power of n, that will then give us this. 4 divided by 3 to the power of n, that will then give you this. So now as n heads towards infinity, this will disappear, this will be 1, this would disappear, and then this thing here, you can simplify this. 3n plus 1 divided by 3n. So it's going to be this, take away this, which will be 1. So this whole thing here will then become this. So the limit of this whole thing here is 3 over 7. So going back to the very beginning of time, we were trying to determine if this series will converge or if this will diverge. So we would use a ratio test. With the ratio test, we would need to know this value here. Well, we've just worked out that the value here is 3 over 7. Well, 3 over 7 is less than 1. 3 over 7 is this value here. This value here is not bigger than 1. So this is out. This value here, which means this value here, is not 1. It doesn't equal 1. So this is out. The only thing that's left is this. So our value is actually less than, this value here is actually less than 1. So it tells us that the test tells us that the original series, which is this here, will converge. So this series will converge. By the way, this test doesn't mean that the series, if you sum up everything, it doesn't equal 3 over 7. The test only we would use this value to determine if it's going to converge, diverge, or inconclusive. This doesn't actually sum up if you sum up this whole thing, it doesn't equal this. We just use this number here to determine whether it's less than 1, greater than 1, or equal to 1. If you sum up everything, it doesn't equal this. By the way, if you want to know if you want to know what it equals to, if you want to sum up this whole thing and you want to know what it equals to, then do this. Hang on. So we are trying. Remember the test. We only use this value here to determine if it's less than 1, greater than 1, or equal to 1. This value here doesn't tell us what it equals to. What if you sum up everything? It won't equal this. Well, anyway, we now want to know. Suppose you want to know what if you sum up this whole thing, what it equals to. Then do this. Rewrite this as 2 fractions. So split this down the middle. So this is 1 fraction plus another fraction. So this thing here, so that's the same as you summing up this and then you summing up this. So that will then take you to here. That will then take you to here, and rewrite this as this. Now this is a geometric series, and this is a constant. You can take it out here, and this is a geometric series. So remember, we've seen this before. There's a formula to working out the summation of the geometric series. It will be this formula here. So if you use this formula, this thing here will become this. This 4 here, by the way, is on the outside. This whole thing here equals this. Because if you look at this, the common ratio here is actually 3/7. That's your common ratio here. That's your common ratio here. And the common ratio here is 1/7. So this R here would be, for this one here, the R is actually 1/7. So that's this R here. So that's this bit here. Well, anyway, if you want to know if you were to sum up everything, it will actually come to this, whatever this may be. Okay?